All right, ladies and gentlemen, welcome back. We've now finished Unit 1 and we're on to the next one. So up next we got Unit 2. Our theme this time is going to be blood diamonds and chemical bonding. Diamonds, one of the most interesting structures in the world. We're going to talk about why and what makes diamonds so unique. First things first, let's talk about today's learning targets. We want to focus on drawing and explain the significance of Lewis dot structures for any element on the periodic table, as well as defining and identifying cations and anions and predicting which ion will form just by looking at the periodic table. So let's give that a go. First, let me make sure that these are the proper colors. Beautiful. Let's move from there. First things first, I want you to think about this. How do valence electrons allow carbon to form bonds in diamonds? This is our focus question for the day, the question we want to be focusing on as we go through the rest of the lesson. So this is lecture 2.1 on Lewis structures and ion formation. What are the types of ions that can form? Now this is a little bit of a review, so I know you guys are used to this, but when we have ions, there's a few different things that happens. When atoms gain or lose electrons, when they're taken away, or an atom receives electrons, they gain a charge because either you have more negatives or less negatives than you previously had. Therefore, you become a charged atom due to the unequal number of protons, which are positive, and electrons, which are negative. So they no longer cancel each other out and are no longer neutral. Now, the two kinds of ions we learned about are cations and anions. Cations are the ions that have a positive charge, and anions are the ions with negative charge. How do we remember this again? Very simple method. Cats make Mr. Astor feel positive. Cations are also positive. Just look at the kitties. Oh, look at the kitties. They're cute, right? Cats are adorable. Cats are positive. Think about the fact that cats make Mr. Astor feel positive, and therefore, cations are also positive. Another little review. Remember our neutral elements. To be neutral, the positives and negatives must cancel out. If the positive and negatives, the equal number of protons and electrons does not exist, then you no longer have a neutral atom, you have a charged atom, otherwise known as an ion. And ions form the same for any specific element. So we can go here to group 1 and we'll find that everything in group 1 forms a +1 ion. Everything in group 2 forms a +2 ion because they have 2 valence electrons, 1 valence electron. Everything in group 3 forms a +3, and so on and so forth. Now you'll notice that it becomes easier to start losing to gain electrons by the end of it, and so they will no longer be positive ions, they'll be negative ions. So the largest ion you could ever get is a +4 ion. It happens very rarely, and we'll explain why in a second, but anything in this group is going to gain or lose 4 electrons. So, how do you draw Lewis structures? Now here's something that chemists use all the time, and I'm going to show you exactly how. Lewis dot structures are the easy way of doing Bohr diagrams. Bohr diagrams take way too long. They're boring. I know, it's great. It's a great joke. Thank you. I appreciate it. It's great. Lewis dot structures, on the other hand, instead of drawing all those dots for the Bohr diagrams, they only show valence electrons because those are the only ones that really matter at the end of the day. Now remember that the group number tells us the number of valence electrons. So Lewis dot structures only have to do with looking at the number of valence electrons in the group and drawing it around the element. Seems hard? Let's give it a shot. Here we have our periodic table, which should help us with everything we need. Don't worry about that for now. So let's draw the Lewis dot structure for fluorine. Fluorine is very simple. We look at our periodic table. Fluorine is in group 17, so it's going to have 7 valence electrons. So if I were to draw this right here, we have fluorine, which if you look on the periodic table, it's got an atomic number of 9 in group 17, or 7A, meaning if we want to draw the Lewis structure, we just do F, 1, 2, 3, 4, 5, 6, 7. And that, my friends, is it. Way easier than you might have thought. Happy? I hope so. Let's keep going. Let's try another one. Let's try carbon. The Lewis dot structures for carbon are pretty simple. Carbon, if you look on a periodic table, will be in group 14. And it has an atomic number of 6. Put carbon right there. So carbon, since in group 14 or 4A, is going to have 1, 2, 3, 4 valence electrons. Easy as pie. Am I right? All right, let's try one more. Last but not least, let's do it for magnesium and then find the charge of the magnesium ion after the octet rule. So I'd find magnesium on the periodic table. There it is. It has an atomic number of 12 in group 2. I would draw it out right here just for reference. (12 Mg). Beautiful. In group 2A. So the Lewis structure would be boom, boom, Mg, 1, 2, since it's in group 2. And since it's in group 2, it's going to lose 1, 2 electrons and become an Mg plus 2 ion because it's losing 2 of its negatives. Done and done. Easier than you thought, huh? I hope so. So go ahead and summarize that for me, guys. And give the around the world problems a shot. And when you feel ready, check out this exit slip. Hope this helped. When you're done, grade yourselves. And that's it for me. Take care.